Good morning. This is Mrs. Bokerman. We are going to start off with teaching you about vectors. So this is the second half of chapter 9. And there's a lot to know about vectors. It's kind of like a whole new world. Polars had its own set of rules, and vectors are going to have its own set of rules. So we're going to cover a lot of the basics in this video. This video is after you've already done the vector voyage worksheet and kind of got an experience of drawing something what we call tip to tail. There's another way to draw vectors if you do more research. It's called the parallelogram method. And you can do that method also, but it's more common to see tip to tail. So you draw a vector, then you draw the other vector, and then you draw what's called the resultant vector, which is actually where you end up from where you started to where you end up. So let's go ahead and get started. A few things about vectors is a vector has both. It has to have a direction and it has to have a magnitude. It can be written in two different ways. These are really interchangeable. You can see them with these brackets around them. So it's not parentheses. Parentheses indicate a point, but if you see these brackets, that's a vector. Or they can be written as something I and something j. I represents anything in the x direction, and j represents anything in the y direction. So vectors break it down into how far are we moving in the horizontal direction and how far are we moving in the vertical direction. And those of you who are in physics, there's a lot of similarities. So some of this you might already actually know. Okay, so the first thing we're going to talk about is position vector. So this is if I was asking you to start at one point and move to another. If it doesn't give you a starting point, then I would assume that you would start at the origin to make your life easier and you could draw it from there. But if it does give you one place to another, you really want to pay attention to the order. So see how it says P1 and P2 and it has this arrow above it. Okay, the way that you find from one position to the other is you actually kind of subtract, similar to you would as slope in a sense. So you take the second point minus the first point and the second y value minus the first y value. So it does matter. Notice we have an A and a B. We have a P1 to P2, but how would that change if we went from P2 to P1? Okay, so let's kind of look at the picture first before I show you the math. Okay, so if I was starting at P1, I kind of graphed 2, -2 is way over here. And I'm saying P2 is over here, which is -8 to 1, which is over here. Okay, and so notice I can actually go backwards now in vector land. I can go to the left. Okay, so I'm going from this point to that point. So what I'm going to do is I'm going to do -8 minus 2, minus 2, and then I'm going to do 1 minus a -2, and that ends up being -10(3). So this is the answer in vector form. Notice it's not parentheses, it's these brackets. And then notice what happens. So from point 1, I'm going -10 in the x direction, so I can literally count -10 this way, and it's a +3, meaning I'm going up 3 in the y direction. So vectors are really how much are you going horizontally and how much are you going vertically. Okay, and it does matter the way you draw your arrow. You're going from one point to the next. Okay, so how would that look if we were doing the second one where now let's go to P2 minus P1? Well, that would actually be going the other way. Notice it's the same vector in a sense, but now I'm going from this point to that point. Notice what happened when you actually did the math. In this equation, I have 10 and -3. So it's the exact opposite. So what that means, and keep this in mind for future lessons, is if you have the same vector, but you have exactly the opposite for everything, that means your arrow is just pointing in the other direction of what the other person has. Okay, so this is a +10, meaning if I was at P2, I would count over +10, and I would count down 3 in the vertical direction. Okay, so it's pretty easy to add vectors. It's pretty easy to subtract vectors. And then if you want to move from one place to another, you have to move the position. So you use subtraction. All right, let's move on to magnitude. So you already know this. It's the same thing as radius when we were in polar world. So the magnitude is basically your r. It is the length of the vector. So magnitude is length. And it's found by using, again, the Pythagorean theorem. Okay. The one thing I want to point out is magnitude we could just ask you like find its magnitude, or we could use these like double absolute value bars. So if you see that, that's not absolute value. When there's two of them, that implies magnitude, which is implying the length. Okay. And then a unit vector is a special type of vector that actually just has a magnitude of 1, which would be seen on the unit circle. Okay. So if I asked you to write a vector in this form, if it doesn't specify like the AI and B, then you can choose the form, and either one is acceptable. I generally like to like the brackets just because it's less to write. But this one wants it in this form, so we have to give it like that. So we want a vector where the magnitude is 4 and makes a 45-degree angle with the positive x-axis. So here's my angle. So I'm going to draw this, and I'm saying that this has a magnitude of 4. I need to actually write the vector. So my answer should be how much am I going in the x direction and how much am I going in the y direction. That would result in a length or magnitude of 4. So the fact that I gave you 45 degrees should be a big hint, okay? Or if it was an angle that we didn't know, like let's say it was an angle of 62 degrees, okay? You could find it very similarly. But because it's 45, I know basically that this for the length is going to equal to the square root of however far on the x and however far on the y squared. Okay, but since it's 45 degrees, x and y have to be the same thing. So I have 2x squared, which then if I do some math and I square both sides, I get 16 divided by 2 is 8, and then take the square root, I get square root of 8. Or if you think about the unit circle, it's just root 2 over 2, but I need a length of 4. Okay, so the correct answer should be this. Either leave it as root 8i plus root 8j, or 2 root 2i plus 2 root 2j. Rationalizing is not required, or reducing the radical, I should say, but you can if you want to. Both answers are correct. All right, so let's write a unit vector given that we're going from P1 to P2. The initial is P1 and the terminal where we're ending is P2. So I would almost think about this graphically first if I were you. So I have -2, 4, and I'm going to 1, -3. And so the first thing I need to figure out is how far am I going x and how far am I going in the y. And obviously, if you don't have graph paper, you can just subtract. So if you do that subtraction, you get 3, -7. And visually, you could see I'm going +3 and then down 7. So that makes sense. So then the next thing would be to find its magnitude. So you take x squared and y squared. So 9 and 49 would make square root of 58. So that means that this magnitude, this vector right here, has a length of the square root of 58. So it's not a unit vector because a unit vector has to have a length of 1. How are we going to do this? If it was 1, we'd be done. Okay. So what has to happen is basically I need to keep the same vector. I want to still go in this direction. Okay, I want to keep the same direction. I just want to change the length. So in other words, I want to scale it back. Okay, a scalar is like something that you multiply by. So if I want to scale it back, what I'm going to do is I'm going to take my vector that I have and I'm actually just going to divide by its magnitude. So this is the right answer. Because now, if I were to square the 3 over root 58, I would have 9 over 58. And if I were to square this, I would have 49 over 58. And since you have a 58 and a 58, you can add the top. And 9 and 49 makes 58 over 58, which would make a length of 1. So anytime you want a unit vector, all you have to do is take the vector that you have and divide by its magnitude. Okay, it keeps it going in the same direction. It's just changing the length. Do you see this blue one making it a little bit smaller? Okay, a few more things about vectors. Vectors can be used for a lot of different things. One of them is to indicate velocity. So a velocity vector is, and it doesn't matter if it's velocity or you'll see the next one is force that we do, but all of these vectors can be written like this. We use V for vector, and then we write it as the magnitude times the direction. Okay, and this is for 2D vectors. Later on in the chapter, we'll get into 3D. But this is the cosine of the angle and the sine of the angle. Okay, this is a calculator chapter. It won't always be angles that we know, and so you can use your calculator, but we ask that you use the whole answer and store it in your calculator if it's not something that we know. Okay, so for example, I want a ball and its initial speed is 25 miles per hour in a direction that makes an angle of 30 degrees with the positive x-axis. Express the velocity vector in terms of I and j. Okay, so the first thing I'm going to do is I'm going to put everything in the right spot. Here in front is where you put the actual velocity because that is the length. So your length is 25 miles an hour. And then here is where you put the angle. So I'm going to write 25 cosine of 30i plus sine of 30j. And then all I have to do from there is basically either use my calculator because it's something I don't know or convert. So the cosine of 30 is root 3 over 2 and the sine of 30 is 1/2, and then I distribute the 25, and so the correct answer is 25 root 3 over 2i plus 25 over 2j. And because you have a calculator, you could give us the decimal. It's not a big deal, but sometimes we like the exact answer. Okay, so again, every single time you put the magnitude here, and you put the angle here, and then you just simplify it. Okay, and you can write any vector in that form. And lastly, same thing, force vector. Notice the only difference, instead of calling it V for velocity, I used F for force, but it's the same exact vector. Every vector needs a magnitude and every vector needs a direction. We need to know how far to draw it and where to draw it at. Okay, so the question is, an object is suspended from the ceiling weighing 1,200 pounds. Express it as a force vector. Well, if you think about this, there's my picture coming down. So it gave me the magnitude, it gave me the length, but it didn't give me the angle. But this is where you need to use your prior knowledge of life. And if you think about it, if I put this at the origin and I'm coming straight down, that's basically going all the way around. And so that's actually an angle of 270 degrees. Okay, then you can use your conversion, or what we would like you to do is get better at if you're going directly east, if you're going directly north, if you're going directly south, it's just an I or J component. And so in this case, it's negative 1,200 J because we're going directly down because this is 0 and this is -1. And so when you distribute, you just get that. Okay, so you are allowed to jump from here to here when you are going directly on one of the axes. Okay, now that's a lot of basic information about vectors. A few last minute things. I found this just to kind of give you an idea of what kind of things we're going to do with vectors or what kind of things you'll do next year in calculus. But a lot of it is velocity, acceleration, momentum, things like that, where there's other things that are scalar because they only have a length, they don't imply direction. You need to know where you're moving something. Temperature is a length or a number, but it doesn't have a direction. So that's kind of, I thought this was a cool graphic for you. Okay, so now that you know a little bit more about the basics of vectors, you should go ahead and check out the Math Excel to see how you learned. All right, see you next time.